All right, so we're going to look at an overview of 9.1 and 9.2, and then look at solving a couple of problems from 9.2. So first, in general, when we're solving quadratic equations, we're going to identify whether or not we have a perfect square equation or a non-perfect square equation. The perfect square equations will have no middle term or no x term. And we can solve those using square roots, as shown in the previous video. Non-perfect square equations will have an x squared term and an x term, and we can solve those as we saw in the previous section 9.1 by completing the square. So we will do this when it's requested or when we feel like it's easier to use that method than these other methods that I'm going to get into now. When you have a non-perfect square equation, if you put it in what's called standard form, so that's generally setting it equal to 0, and then looking at the coefficients of each of the terms, the x squared term, the x term, and the constant term, and identifying those coefficients as a, b, and c. And if we can multiply by some values so that a, b, and c are all integers, and that a is a positive number, that's going to be what we call standard form. And if we get it into that form, it's going to make the next steps in the process easier to do. So for one, if it's factorable, we'll be able to tell more readily once it's in standard form. And if it's factorable, we can then solve it by factoring. And then if it's not factorable, or if it's difficult to try to factor, then we'll use the quadratic formula to solve. So these are the two ideas in section 9.2 for your homework. And if we are using the quadratic formula, what we'll want to do is explicitly identify the coefficients a, b, and c, and actually rewrite the formula before we use it. So what do I mean by that? Is, we're going to explicitly write out a equals this number, b equals that number, c equals that number, and then we'll rewrite the formula, which is here. It's good to sort of learn this and say it out loud. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's what's known as the quadratic formula. It solves equations like this one up here in red, ax squared plus bx plus c equals 0. So that's the overview of solving quadratic equations. And let's see if I can get that whole thing on one page here. So if you wanted to pause the video and look at the whole thing at once, you could. And maybe I'll just move this over. Nope, doesn't like that. So I can get the formula on there. I can't get the a, b, and c on there. Okay, so there's solving quadratic equations. Take the space out. An overview. All right, let's look at an example. So we're going to solve this equation, and the instructions would say by factoring or the quadratic formula. So we'll notice it's not a perfect square because we have a middle term of x, 1/8 x squared minus 1/4 x plus 1. It is also not in the standard form because the coefficients, well, two reasons. It's not equal 0, and the coefficients are not integers, they're fractions. So I want to get rid of those fractions. So I will do that by multiplying everything by the LCD over 1. In this case, that's going to be 8. So I'll come in here, times here by 8 over 1. Squeeze in there, times by 8 over 1, times over here by 8 over 1. Timesing by the LCD over 1 to cancel the fractions. Okay, so what do we get? The 8 over here cancels. We get x squared by itself. Four goes into 8 twice, so we get minus 2 times x. And that is then going to equal, on the right-hand side, 8. And then I want to set this guy equal to 0 so that it will be in standard form. So I'll do that by subtracting the 8 from both sides. Once I have it in standard form, I'm going to ask if this factors. So does this factor, or is it easy for me to factor it? If the answer is yes, then we want to factor it. So we're looking at if it does factor, because the a here, so one thing to notice here is what are a, b, and c, just to get comfortable with this idea of identifying the a, b, and c. When we do use the quadratic formula, a here is 1, the coefficient of x squared, b is -2, and the c is a -8. If we were going to use the quadratic formula, those are the values of the a, b, and c coefficients. But in this case, we see that this guy factors because I get x and x for free. X times x is x squared. Looking at the factors of 8, 1 and 8, and 4 and 2, I know that one of these is positive and one is negative. And I'm looking for a pair of factors of 8 that add up to -2. So it's going to be a -4 here and a +2 there. That would give us a +2x in the middle and a -4x on the outside, adding up to -2x. So then once this equals 0 and is factored, we can set each factor to 0 as we did before. So x + 2 = 0, or x - 4 = 0, and then we solve these, giving us x is -2 or x is 4. And those are our two solutions for this problem. Okay, I'm going to look at the next problem now. I'll pause. And if you need to pause and write this down, you can as well. And this problem, 2x times x - 1 = 3, we can see that it's quadratic because if I were to multiply the 2x times the x, I'm going to get a 2x squared. I can also see that I have an x term, so I have 2x squared minus 2x on the left side of this equation really equals 3. So that's actually the first thing I need to do is to multiply this out to try to put it into standard form. So, and it's not cooperating. I'm going to multiply this out. In an effort to put it in standard form. So we get 2x squared minus 2x equals 3. And then it needs to equal 0 to be in standard form, so we'll move the 3 over. 2x squared minus 2x, subtract 3 from both sides, minus 3 equals 0. So now it's in standard form, and notice that the coefficients of each of the terms are integers. They're not fractions, they're not decimals, they're either positive or negative whole numbers. Additionally, the a value is positive. So let's identify what a, b, and c are for ourselves. Here's my pen. So here, so this is what I mean by explicitly telling yourself or writing down for me what are a, b, and c. It makes using the quadratic formula much easier. A is 2, b is -2, and c is -3. This equation must be it must be equal 0 for sure to be utilizing the quadratic formula. And then it's much easier to use the quadratic formula if the values for a, b, and c are all integers. Okay, so now could I factor this? Well, you know, as soon as this coefficient is not 1 in front, it's harder to factor. If we were to factor it, we could use AC grouping or AC magic. I'll look at this real quick and I'll say, well, 2 times 3 is 6. Are there any factors of 6 that are going to add up to 2? Well, 1 and 6, no. And 2 and 3, no. So this guy is not factorable. So then I would use the quadratic formula. And what I like to do is always write the formula down before you use it. This has a couple of advantages. It has the advantage of, it helps us remember what it is. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It has the second advantage of, when we go to plug the numbers in, for a, b, and c, I can, if I have the formula written down and I know the value of the computation, I can just do the computation without having to write this down. So what is negative b in this case? It's the negative of negative 2. Well, if I negate negative 2, I actually get a positive 2. So this is positive 2 plus or minus the square root of, and again, if I know the value of b squared, so b is negative 2, what's b squared going to be? That's going to be 4. I'm better off writing 4 here than writing negative 2 squared. Chances are if I write negative 2 squared, I'm going to get negative 4. So it's, if you know the value of the computation, go ahead and do it as you write these down. This is the value of having the formula written down. And then I'm subtracting 4 times a times c. So again, I can figure out what that is. 4 times 2 is 8. And it's being a little bit finicky. 4 times 2 is 8, times negative 3 is 8 times negative 3 is negative 24. It's a minus there, so that's going to become a plus 24. Or I can write it out. 4 Here I wrote this out. It's a minus 4 times 2 times negative 3. That's going to become a plus 24. So sometimes it would be easier just to write that in automatically as opposed to putting those values in one by one. And then the denominator, everything over 2a. Again, what's 2 times 2? 2 times 2 we know is 4. So that's better to write that in if you know it. And this becomes a 2 plus or minus the square root of, so that's a 4 plus 4 times 2 times negative times 3 is 24, all over 4. I need to simplify this, so this is 2 plus or minus the square root of 28, all over 4. And then I need to reduce that square root of 28. So 28 is 4 times 7. So that's 2 plus or minus 2 square root of 7 over 4. And then I'd like to, if I can, reduce this guy down. So if you're going to reduce this fraction, the value that you cancel has to cancel all 3 pieces, meaning the 2 terms on top and the term on bottom. So what cancels here is a factor of 2. And I could come in here and cancel these 2's out and make them 1's. 1, 1, and cancel that guy out and make it a 2. So we'll get as our answer here, x is equal to 1 plus or minus the square root of 7 divided by 2. Now, unless our answer is complex, when we enter this into the computer, it's going to want 2 separate answers. So this is not a complex number. There's no imaginary I here. So when we enter this into XYZ, it's going to want us to do this. 1 plus the square root of 7 divided by 2, comma, it's one of the solutions, and the other one is 1 minus the square root of 7 divided by 2. I just want to go back up here for a second, so if you need to pause the recording, do. Or I'm going to roll back up and just go back to the key points here. We multiplied this out and set it equal to 0. Having done that, I then identified, well, first I checked if it was factorable, and it was not. Then I identified A, B, and C, meaning I wrote it down, A equals B equals C equals. I also wrote the formula down for the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Then I plugged all the values in and simplified. So you can see in this simplification, there's a lot of room for error here. There's a lot of room up here in this sign for a mistake. There's room in here when you're reducing this root for a mistake. There's room in this fraction when you're reducing that down for a mistake. So what tends to happen with the quadratic formula is there's lots of little places where we can make mistakes, and each of those little places is an opportunity to, again, make an error. So if the original was factorable, usually it's much easier to go ahead and factor it and solve it with that method.